Welcome to the August session of OWASP Vancouver. We have 4 exciting speakers for you, and our first one is Vivek Ponnada, speaking about secure coding of industrial control systems. Vivek works for GE as a service manager and is responsible for GE's gas power transactional customers, utilities, and cogeneration across Canada. Prior to this role, he was in sales and business development of control systems, upgrades, and cybersecurity solutions, and started his career as a field engineer, commissioning turbine control systems in Europe, Africa, Middle East, and Southeast Asia. Vivek is passionate about industrial control cybersecurity and enjoys learning and contributing to the security community. So with that said, Vivek, it's over to you.
All right. Thanks, Fashad. Hey, folks. Thanks for having me again. This is good. Just a quick background, my contact info here. My background is industrial controls. I've been a technical and then a business development person in industrial controls upgrades, and cybersecurity is something that I started off a few years ago as a kind of interesting side gig, as learning and also contributing, and then over time kind of took more and more responsibility. So let's talk a little bit about how industrial control systems are coded today and the improvements that we're recommending. Next slide, please. Quick agenda here. I'll give you a little bit of background about what these industrial control systems are and how we program them currently, and the project that we started called the Top 20 Secure PLC Coding Practices. This was hosted on ISA, and it's now officially released. It's a document that you can download, and both the end users, the EPCs, engineering, procurement, construction companies, and the vendors can utilize them. So I'm going to talk through a few examples and take any questions. Next slide, please. All right, so one more, maybe that'll give you the picture as well. Okay, excellent. So you'll hear these terms, PLCs, DCS, and SCADA systems. These are all different control systems at Purdue Level 1. We'll talk about that Level 1 in just a second, but this is how they look. I mean, you'll see pictures of these ICS villages or maybe IoT villages. They all look very similar. Those of you that are playing with Raspberry Pi, you'll be pretty familiar with how these devices work, right? So you'll kind of connect some kind of power supply at the top, and you'll have a controller in the middle, and maybe some kind of peripheral connections. We call them IO, input-output devices. Those are the black ones below the main controller that you see. And then historically, the commonality with all these control systems is that they didn't have any encryption, they didn't have any authentication, because at that level it wasn't important. Functionality-wise, those were not things that industrial controls were asked for or required of, so they were never involved. Next slide, please. So this is the Purdue reference architecture that I mentioned. If you see at the very bottom, this is a hierarchical, so you'll see level 0 at the very bottom, which is field instrumentation like transmitters for pressure, temperature, and things like that. And then if you go above, level 1 is a controller. These are the controllers we're going to talk about programming. One level above is the human machine interface, which is the what is currently pretty much understood as OT, which is IT assets utilized in the industrial controls world. So operator interfaces, Windows computers that you see at that level. And then one above that would be level 2 and 3, which again is mostly IT assets repurposed or custom built for OT applications. So you'll see a lot of these assets that are both HMIs, human machine interfaces, but also engineering workstations, historians, and so on and so forth. And about that is typically, traditional enterprise IT zone with some kind of DMZ or jump server applications there. But this kind of picture helps you kind of figure out where the attack vectors are, and how in typical industrial applications the plant network exists. So historically, most focus on security was top down, meaning your enterprise IT is affected first, and OT is kind of far below, not directly connected to the internet. But of course, thanks to industrial IoT, and of course, cloud service providers providing some additional value. This has been breached a long time ago. This network is kind of theoretical. You might have a lot more plug-in points to the level 2 and level 1 that you haven't really planned for. But this particular project, we're going to talk more about the programming of level 1 devices. Next slide, please. All right, so there is an IEC 61131-3 programmer logic controllers programming. These 5 different programming types, just like in traditional IT, not just one programming language. You have a whole family of programming languages, and historically they were used for different purposes. So the first example you see there about the ladder logic, that's the most popular one that you'll see in pretty much all PLCs. This was from historical relay-based logic, essentially how I/O was connected way back when using physical relays. So that's why the term relay logic or ladder logic came about. So you'll see that it kind of looks like a ladder that we all use, right? Like a step-up ladder. In this example, if you see like switch 1, switch 2, if you were to light them up, if those relays get activated, then that motor starts on the right. So that's the way to read that logic. Or if you see, the second rung of that relay logic, you press the manual button, so that lights up, and then you can also start the motor that way. Couple more clicks, please. So next up is the function block diagrams. Again, the intent is to start that motor, right? So that end result could be starting the motor, but now you have a depiction that's slightly different. So you have now this function block type programming where you can see and add any operands, if you will, and instead of coding using relay logic, which most older folks tend to do, you have a slightly more advanced view of this coding type. And then the instruction list, the number 3 list, it's not as popular, but you can do it that way. It was deprecated a few years ago for better ways. So the structure test that's coming up next, that's more popular these days. It looks more like a programming language. One more click, please. This, as you can imagine, looks more like a basic or a relatively modern language. Doesn't look like any Python programming for sure, but it does look more familiar to traditional IT programmers, as in you can use ifs and else statements and type your program in a text pad if you want to, and then upload to the controller. And then finally, one more click, please, sequential function charts. These are used in more complex applications where it's kind of like a flow chart where you might use all these other types of programming languages, ladder logic or structure test, but then you put that in this particular sequence. Next slide, please. All right, so a couple of years ago at a security project, not project, but a conference called S4, Jake Brodsky did a presentation about how historically we'd never really realized these PLCs can be programmed with security in mind. And out of that project came this community project to actually codify and bring out the list so that more people can apply them. So we had 1,000 contributors that kind of got together over a period of a year. Every couple of weeks we met and we kind of put some examples together and made sense of a bunch of different things that Jake mentioned. And now we have a formal document that you can download and use for whatever purpose. Essentially, these are best practices, so nothing proprietary about it, and not specific to a particular PLC or a control system. Next slide, please. So one more. So we have these top 20 practices now. Some of them are quite obvious. So you'll see 10 on the left, and one more click, you get 10 on the right as well. Some are pretty basic, like the first one that talks about modularizing PLC code. You might chuckle, this is, build code in segments. That's what it's essentially saying. But historically, that was not done everywhere. The reason why we put these very seemingly basic, seemingly obvious one in is because a lot of these programmers that are starting new or maybe learned some bad ways historically continue to do so. And so, doing any forensics during IR or even kind of standardization of code and porting the code from one known good condition to another has always been difficult. So we put some practices that are very basic and still not followed. One more click, please, so you get the whole list of all 20. Yeah, and then if you see some on the right, like logging PLC uptime number 17 or logging PLC hard stops number 18. These are what we call monitoring practices. So some of the practices on the left are more about how you program and actually code the sequences. And then a few on the right, these are monitoring where, these control systems have some features where you can monitor their memory usage or their uptime, but they were not logged or tracked for security purposes. So we kind of put together a list of those monitoring practices that you can use if you enable them, and you're helping yourself during a post-ransomware incident in remediation or forensics, and then helping yourself getting back up online quicker. Next slide, please. Dana has a question. What are your thoughts on, couldn't read it, get back to that. OWASP project to better circulate the top 20. Yeah, it's a good question because we're trying to reach out to different segments of the population, right? We're trying to reach out to vendors of these control systems so that they can incorporate these functionalities or maybe put them in the projects if the control system has a functionality but not actually utilized in the project. Similarly, more distribution amongst actual engineers that do the programming could be, folks such as y'all that are interested in it, or maybe folks that are part of other groups like IEEE or ISA, essentially get into the hands of more people that actually program these devices and people that are learning today, not just ICS systems, also IoT systems, because they share a lot of this coding practice. So in this example, integrity, you'll see, validating inputs based on physical plausibility. This is kind of interesting. In one more click, please. So I just took the same example, the functional block example there. I would request you to be a little bit imaginative and think that this A and B here are kind of some kind of feedback coming from a gate that you commanded to open, right? Like a dam where there are a bunch of gates and they take a certain time to go from, fully closed to fully open. Because it's a physical event, exactly how much time it should take from close to open based on the physical characteristics of the gate itself, right? Maybe there's a piston behind it, or maybe there's some other lever. Either way, if it goes fully closed, from fully closed to fully open in an expected duration, that's great. But if it doesn't, then it could be a physical problem, right? The gate might have an issue, or it could be that someone is manipulating those packets on the network as if it's actually closed or open, right? So that thing is pretty easy for a PLC to realize, because the PLC is monitoring the condition of so many inputs and outputs that you don't need any fancy detection. You don't need any fancy intrusion detection outside of the network to realize if this is physically plausible or not. So if you have a simple timer to say, usually this gate goes from either way, right? So from close to open or open to close in X number of seconds. but now suddenly it's 10x that, or lower or higher. You can alert now, whether it's security related or a physical mechanical issue at the gate, or a sensor issue. That's a second tier problem. You can do some digging in, you can troubleshoot later, but at the very least you can alert, and that gives you a very basic recognition of the fact that something is wrong. And historically we did that for plant troubleshooting purposes, so to understand if a sensor, the feedback sensor, is correct or not, but we never did that with security in mind. So that's one of the recommendations of this practice list. Similarly, monitor expected physical activity. If you have a water treatment plant that does some cycle in the morning, some cycle at night, and suddenly the behavior changed, if someone was manipulating packets and forcing a particular vessel to drain quickly or drain at a different time compared to what it should be, same thing. You can alert it, and without any fancy third-party detection, even at a firewall level or a network sensor level, at the PLC level itself, because of all the I/O, all the recognition of the inputs and outputs, you can easily alert that something is wrong. And then the last one, limit operator entry for set points to what's practical and physically plausible. If you all remember recently, at the Florida water treatment plant, someone got credentials for remote access, and they tried to lie, about 10,000 times what the level should be. There were many things wrong with that picture. We're not even talking about the securing remote access, but the operator being able to enter that high of a value, that itself is wrong, because there's no way physically that much lie can be added in a given time period, right? 10 minutes or 1 hour or whatnot. So in this example, we're saying, enter, the operator should be able to enter values that are reasonable and practical for the process, right? That way, if you're limited to 0 to 10, if the amount in the process can only take that much, that would have limited any operator entry outside of it. So that'll catch any errors that the operator might make. And at the same time, it also avoids having registry and memory allocations that are way outside of the requirement, and also maybe keep your logic cleaner, because then you don't have to ramp up or ramp down from a much higher number than it's required for that particular process. Next example, please.
Vivek, I just wanted to give the time check. We're at time, but we can go for another 5 minutes or so.
Sure. Yeah, I'll just quickly go through this one and end it at that, because then they can follow with the previous presentations on DEF CON. So this is another popular one, track operating modes. So this is the same PLC example that I showed on the previous slides. So you see that middle controller has a key switch. Some of these controllers have a physical switch that can lock you in either run mode or program mode. And a lot of network engineers or programming, PLC programmers leave it in, remote run mode so that they can download to the controller from far away. Usually that's because these PLCs are in hazardous locations. To actually physically go to the site, you might need to put on coveralls, you might need a permit, but if you just leave it in remote program mode, you can, over the network, download to the controller and make any changes that you need to. But of course, that makes it an attack vector, right? So that is in run or remote program mode. Somebody else other than you might be able to access it, coming through the IT systems and download to the controller. This actually happened in a safety PLC in Saudi Arabia recently. So again, the recommendation is track those modes and alert if it's not in run mode. So if it's in program mode and happens to be in remote program mode, an operator should get an alert. Now, we're not talking about SOCs and fancy alert systems that the industrial controls don't have, but they typically have 24/7 monitoring or some kind of operator visibility for alarms, what we call alerts in the IT world, they call them alarms. So yeah, the recommendation here is to track those modes so that, on a per shift basis, if somebody is not supposed to be playing with the controller, not supposed to download to the controller, they shouldn't be able to do it. So put that in local run mode so that if someone needs to program it or download it, they should be physically there, or have a permit and have a physical operator switch it to run mode, remote mode, so that they can download it from the remote. All right, folks, I think that'll be good enough examples. We can share these slides if you all want. More information available at that plcsecurity.com. And let me know if you have any other questions.
Let me just take a look at the chat, see if there are any questions here. Thanks, Vivek. That was an excellent presentation. I didn't catch this. I believe you presented the slightly longer version at the Pacific Northwest AppSec conference, and I missed it. So it's good to see this version here. So thank you very much. Very informative. Sure. My knowledge is pretty limited in this space, so I just gained a whole bunch of new knowledge. So I thank you for that.
Not at all.
Questions, comments, and yeah, and that project would be really good to take it up and formalize it if that is a possibility. I think it'd be quite valuable to turn it into an OWASP project. Okay, so there seems to be no questions on the chat, and given that we're running a little bit behind, once again, I thank you for the presentation, and on to our next speaker. Second speaker, Jared Meit, automate ZAP in any language. Jared has always had a passion for taking things apart, learning how they work, and forgetting how to put them back together. He brings more than 12 years of professional software development and a zeal for all things security. His AppSec experience at one of the big four accounting firms informs the deep level of care and scrutiny that he applies to all the projects, and he currently works at Forward Security and tries to not break things. With that said, over to you, Jared.
Thanks. Can I share my screen?
Absolutely. Let me just stop sharing. Go ahead.
Okay. I don't know how I'm going to fit this into 15 minutes. We're going to try. This is automate ZAP in any language. Any language. This is my lightning talk. Okay. So it's almost any language as long as they can make web requests. I did want to try to create an example in some really obscure language like brainfuck or something like that, but it wasn't possible to make web requests in there. So about me, this stuff, and let's show you stuff. So the one thing about the about me that's important is that being a polyglot is good. Being able to write and read in as many coding languages as possible doesn't just make you useful in the industry, but it's different languages are built to do different tasks and make you think in different ways. It's good. Demo time. Okay, so let's go to, so I've set up a GitHub repo, which I'll share with you guys all at the end. It's in my last slide. And essentially what this does, it's a tool that I've built that's going to help you all, everybody who uses ZAP, anybody who's, first of all, does anybody use ZAP? It's pretty much a prerequisite to understand what's going on here. Has anybody heard of ZAP? Can I answer the question, what is ZAP for somebody? Does anybody know how to use the raise hand feature or the
hand feature? I don't even
share a fire emoji in the chat.
Where is that? Oh, reactions. There they are.
Burp Suite Pro, man, myself. Yeah. Okay. All right. But yeah, let's get a little less bragging in the chat. How about that? No, I mean, listen. Burp has its place. It's ZAP has its place. It's open source. You can freely distribute it to people. You can put it in their DevSecOps. And Dana, you're absolutely right. So for those of you who don't know, ZAP, it's very similar to Burp. It's kind of like the open source alternative to Burp. It's newer, so it's a little bit less mature. It doesn't do as much, but it does a lot of the same things. Because it's open source, you can stick it in your client's DevSecOps as a free DAS tool. And it's from OWASP. That's absolutely right. Made by a brilliant guy, Simon Bennett. So what he has done is create so ZAP has this nice GUI, and just like Burp, you can go in and do all your burpy things and zap away. He also provided an API, which makes it great for automating. So especially if you're going to put this in someone's CI/CD pipeline and have it run after deployment, you can't have somebody, I don't know, every time you hit the deploy button, go send a vid screen to a mechanical Turk and have them click through all the ZAP features. So it's much better to have it automated through scripts, right? But you might write in, that's right. So, so I was reading the chat there. That's right, Marsha. It's made for devs. Less so for pen testers, more so for devs. What was I saying? So, right. So when you're writing scripts, you don't want to have to learn. I mean, it has a scripting engine in it, but I don't want to have to learn Java. I've written Python all my life, or I don't want to know how to write Python. I've written in, I don't know, Pascal all my life. So as long as there's a language that has that can make web requests, I've written a little tool to make it so that you can access their API with whatever language you're using. That's the benefit of this. Okay. That was the problem I was trying to solve for. We had a thing written in Ruby. There was already an implementation written in Python, which I didn't think was very good. So I thought, I want to rewrite this Python one and also write this Ruby one, which we actually need for a job. So here's what the tool does. It's very simple. And I'm going to explain it to you, and then you'll go, oh, I could make that. Well, don't. I made it already. Okay, just download it. But essentially what it is it scrapes the API page that ZAP produces. So if I go ahead and open up ZAP here, let's see, I've drag it onto this screen. I'm just going to actually delete the history that I've created while testing. And it is frozen. I did not make a sacrifice to the demo gods before this. Okay, let's quit that. And we'll try it again. So basically what I'm going to show you here is in the GUI, there's an option to allow you to browse the API. Browsing the API opens up a tab in your browser, and you can actually make web requests from that page to sort of demo how they work, and it also sort of acts as documentation. So what I did was write a scraping tool which is specifically made for that documentation page. It goes and it creates a huge JSON file with every single possible endpoint and all the parameters that it needs, including what is required and what's optional. And I'll show you how to use that in a moment. So here's ZAP for those of you who don't know. The first thing I'm going to do here is I gotta get rid of these Zoom window thing because I can't see past it. Let's go to Tools, and why is everything grayed out? Okay, this is the first time I've ever seen this not work. Tools, browse API. Is it still starting up? Is it? It knows that I'm getting a presentation. That's what's going on here. And it's frozen again. Interesting. Maybe it doesn't like when I drag it to the other window. I don't know. Well, imagine that what you're seeing is a nice page that you can click through all the various functions that ZAP has to offer. So this collects all of those and puts them into a JSON file. This is actually the file that it produces. I keep a copy of it in the Git repo, but you can, of course, the purpose of this tool is that you can open ZAP. All you need to do as a prerequisite is have ZAP open, run the tool. Usage is right here, pip and run, and then the run.sh. You need to install pipenv for this to work. It's a Python environment tool, kind of like virtual env, if anybody's familiar with that. So all it does is it calls Scrapey, which is a pip Python tool, which will get installed when you install this. And it runs a spider and it calls my script. And at the end, you end up with this big fat JSON file. So let's see what this looks like. So the first, it's alphabetical. So the first object that we pick up here is the a CSRF. That's the, I believe, active CSRF object. And in here are all the functions that you can call within it. And you see they're camel cased. It's going to become important a bit later on. Inside, we've got the parameters and whether or not they're required. Okay. Parameter name, requirement, Boolean. So this is for ACSRF. How about Ajax Spider? Here, maybe in the Ajax Spider, we want to get the full results, or we want to, there is a function for start, maybe scan, is this it? So there's the scan function inside the Ajax Spider. And there's many more. So in order to make this useful, you need to keep your, the API documentation open in a tab, just so as a reference. That's your documentation. Okay, so how do we use that? Let's take a look at some code. So after you've run this, it produces the ZAP API JSON file. This is now a complete record of all the possible API calls that you can make to ZAP, and makes them accessible to you to create an interface. So I've created an example interface here. Okay, so here is, start with main. So here in our, this is my Ruby example. So what you do is you take your JSON file and you start building a small interface. It's very easy to do. In this example, we'll show you how to do it in Ruby, and it's easy to implement it then in other languages just by looking at this. So essentially, at the end of the day, you're going to import your interface, which we'll get to in a second. That's where all the magic is. It produces this object that you instantiate with these parameters. And all of a sudden, you can now call functions on the ZAP object. So there is an object, there's a ZAP, let's say a class with that core that has a method version. This is how you get the version number. And I use this to make sure that ZAP is working properly. I'll explain this array key at the end. In order to distract, it's not totally important, but it is there. Here's another example. There's the Open API class for importing Open API files from a URL or from anywhere else. And inside this class, we have the import file, camel cased, function. There's only ever one layer of like, there's only ever one, a class with methods in it. It doesn't go any deeper than that. So you'll have class name underscore function. And then in it, you pass the named variables, the named parameters. These named parameters you can find in that documentation that ZAP provides. And actually, while I'm talking, I'm going to try to open it one more time in the background. Okay, while that's going, let's keep going. So a scan, this is active scan. We want to enable all scanners. Now that all scanners are enabled, I want to call scan on a scan, and I tell it what I want to scan. Here I'm scanning Juice Shop. If it wasn't clear from, this is the Swagger file I'm using, and a classic port 3000 for Juice Shop. So what this does is it starts an active scan in ZAP. So actually, if you have a ZAP window open, now in your CI/CD pipeline, you're not going to have a ZAP window. It's going to be the demonized version. It has a non-GUI demonized version you can run. But when you're testing this on your desktop or your laptop, you're going to see the GUI actually start to scan. And this, while it's going, I've got a little progress check meter. It's going to keep checking the status of that scan. And you can actually see in the ZAP window that it's going. And once it reaches 100%, it quits. Okay. Now let's get into the meat and potatoes. Okay. So here is my interface. This is where I take my JSON file and I, down here, create my methods. So very easy, very simple. First, let's talk about this API variable, which we're looking at. So basically, I take the JSON file and I parse the JSON file, right? Now we have an object that contains the data from our JSON file that the scraper created. Let's go back down to create methods. We're going to go through each of them. We're going to get the name. ZAP calls the classes components. So ascan is a component, Open API is a component, and then the functions within it. So for each function that's inside of there, we're going to take the name and the other data inside of there, which is the parameters and whether or not they're required. And Ruby gives us this nice define singleton method. Most other languages have this too. PHP does, Python does. This is basically how you create a function programmatically. Kind of like, almost like meta programming. We're on the fly creating a bunch of functions. So here we're giving it, you see the underscore here, you recognize that. So this first part is the component name and then the function name. So it creates a function with that name. And then it goes in and adds the proper parameters, the named parameters. Okay, so that's all we're doing here. Very simple. The rest of this stuff is just fluff. Here I've made a convenience function called request, and every single request requires an API key. And I'm pretty sure also every single request, is a GET request. So you can see there's a very specific format for the URL when you make a request to the ZAP API. So as long as you follow this, because all you're doing, right, what we're doing behind the scenes is making an API request to ZAP. So that's where this is happening. So basically when somebody calls a function, so this is what's happening here. We're defining a singleton method with that name. And when you call it, it calls our request function up here, right? And it calls it with the component name, the function name, and then the params. This type is specifically related to some ZAP stuff. Some things return JSON, other things return other. Basically, I would just take this very simple logic and convert it into whatever language you're using. So if you have these two functions, you have the basis for calling ZAP in any language, right? So now when I instantiate this class, this start ZAP thing is a to-do. I can take this out for clarity. That was to, so you didn't have to open the GUI. So again, what are we doing? When we create this object, we pass in the path to the JSON file. This is just the default path. It's what worked for us. You can pass in anything else that's necessary for ZAP. So you need an API key. You might want to pass that in if you're using a specific port other than the default, if you're using a different host, if it's not on the same server, etc. This zap.bin is for the function I just deleted. So you need to make two things: a create methods function, and again defines functions with this nomenclature, component underscore function name, camel cased. And then what that function will do is call this request function. It's going to make an API call. Okay. And it's going to make an API call in this format. This format is specific to ZAP. So just copy this into whichever language you're using. I don't know if there's more to explain. I went pretty fast. I guess I could have gone a bit slower. I was worried I'd run out of time. Because I went so fast, I probably skipped some things or was unclear about some things. Please ask me questions, and don't be afraid to make me repeat myself. Oh, 14 questions in the chat. Oh no, need to drop. Great job. Does ZAP have some function to generate the API key already? Yes, I don't, but it's sort of a catch-22 because in order to use the API, you need the API key. So what you can do when you first, so in your CI/CD pipeline, when you go to run ZAP, now again, it'll be in the demonized form, the non-GUI form, you can actually pass, one of the parameters you can pass to it is the API key. So you'll store that API key in maybe your CI/CD environment variables in the secure storage, and make it, print it when you're running when you call the ZAP daemon. But also the API key it's not really, I mean, the ZAP daemon is only on for the amount of time that you're doing the scan, and then it disappears if you're doing it in your CI/CD. So it's not so important to keep it super, super secure, this particular API key. I think, is there I'm just looking at stuff in the chat. Yeah, so this ZAP API key that you saw there, feel free to spread that around. It only works on my laptop when I have ZAP open, and it's not in a DMZ or anything like that. So I think there's actually a button that's generate random API key, which is how that came about. Okay, so I guess we're at the end here.
So Jared, you said they've added an API key generator. Dana, I think, was asking about that. Does it have some function to generate the API key?
Yeah, if you want to generate a random one, yeah, there's a GUI button for that. But again, if you use the command line to start up ZAP, you can pass to it an API key. So you could use bash to create a random string, and then pass it as a CLI variable. Yeah, that's right. Since ZAP is always freezing, that's pretty much my security measure, is the fact that it doesn't seem to be working on my computer. Makes me super secure. It's still not working. Very interesting. All right. Maybe there's something about having Zoom open. I don't know. ZAP has stage fright today. But I think you guys get the idea. At the risk of cutting it off, that's my time.
And Dana, thank you for sharing the link to Jared's GitHub. I will reshare that one more time.
Yeah, it's here as well. The ZAP API generator. So you'll find it. My username there is Meit, Jared Meit, MEIT, and then the ZAP API generator. Thanks for sharing it in the chat. Thanks for the chat claps. That's all.
Fantastic.
Please share. Oh, by the way, if you do write some interfaces in other languages, share it with me. I will put it in the examples folder. It would be good to have examples for other languages.
Awesome. Fantastic. I guess there's no more questions. If they are, feel free to reach out to Jared. Once again, a huge thank you. An awesome topic, great talk. I'm sure many of us really enjoyed it, and there's a lot that we've learned. So thank you. With that being said, I am going to introduce you to our next speaker. Our next speaker is Harsh Modi. Actually, I know him personally too, so welcome. A little bit about Harsh. He has 2 years of experience as a pen tester with various orgs, including within Vancouver. He is a dedicated cybersecurity professional and mentors 6 people worldwide on various ethical hacking techniques. In his spare time, Harsh likes to get extremely technical with his security skills and looks forward to writing his OSCP and SYNAC Red Team exams in the future. With that, I'm going to hand this over to Harsh to take over and present.
Thank you. Thank you. That was quite an introduction. Thank you. Thank you for having me. This is my first time presenting at OWASP Vancouver. My topic is learning cybersecurity the hard way. By the hard way, I mean learning more technical stuff and things that are required on an industry level, how to exploit a system and basically everything related to it. We just start so who am I? As said by Arti, I am a penetration tester for 2 years. My specialty is in web, mobile, network, and binary. And last year I mentored around 6 professionals, and I am very proud of that because actually I started it to distract myself from this other stuff going on in the life, other unexpected stuff going in the life. But this is something I'm very proud about it because now they are really successful in their field. After that, I did some 3 or 4 contract jobs in Vancouver with local companies like Mirai and others. And currently I'm hired as a penetration tester at Optiv in Toronto. And probably I have to move to Toronto in a couple of months. And if anyone is in Toronto, I would definitely meet them in Toronto. The purpose of this talk is this should provide a guideline or a roadmap on how to understand the technical aspects of a pen test, or what are the skills that are needed when you pen test a client, and what are the open source resources, labs, and everything available on the internet. One more thing that is required is the attitude of try harder. That is the motto of OSCP, Offensive Security Certifications. This talk would be focused only on offensive side of the cybersecurity. That is the red team, that is penetration tester, security analyst, and other job roles and responsibilities. The other two teams are blue team, that is the defensive side, and the third is the purple team, that is a kind of a bit hybrid. The first step that I normally recommend to people who are a beginner in this industry is know your local community. For example, in Vancouver, there is OWASP Vancouver, we have ISACA Vancouver, BSides Vancouver, and other communities, so that you can meet like-minded people. You can ask about what they are researching and how they are researching, and you can contribute with them. They can share knowledge, and you can move ahead in the field. But if you are here, that means you already have done this first step. So the second step is, if you're completely unaware of the cybersecurity field, then I would highly recommend the OWASP Top 10 and the testing guide. This is kind of a methodology or a checklist written by the industry professionals from all over the world, and they also have written the prevention cheat sheets. And the latest version is 4.1. It was released last year. I am not sure whether it was released. Any new versions were released this year, but any version is compatible when you're learning as a beginner. From this side, everything practical will start. For the first thing that I highly recommend is to play CTFs. CTFs are the capture the flag events that are hosted by various organizations or companies for people to play and practice and demonstrate their skills. There are two types of CTFs, but we will mostly focus on Jeopardy style, which is a category of challenges which includes web, crypto, forensics, and reversing. Why I prefer CTFs is that it is a real time. It kind of for a person or a hacker, it kind of brings that mentality of enumeration and how to research. Research is very important in cybersecurity, as there will be times where you do not understand specific aspects of a target or anything. So capture the flags. How to start capture the flags? You can read write-ups from GitHub repos, and the best site for CTFs is ctftime.org. You can go to this website and you can see which are the upcoming CTF events. I personally started playing CTFs in 2018, and the first CTF I played, I could not solve any challenge. And after the time, recently I won a CTF challenge. So that is like my 4 years in the field. The CTF challenges that I recommend for the beginners is Over the Wires, Bandit, and Natus. There are like 30-35 levels in it, and the difficulty level increases slightly in each level. So you do not there is not a jump in difficulty level from first level to 10th level or 15th level. The other CTF that I recommend is the Pico CTF. Pico CTF is only for beginners. They have like 1 to 5 levels, but the first and second level are always for the beginners. Any other CTF or upcoming CTF that you can find on ctftime.org with the label beginner level, you should go for it. Yes, walkthroughs. There are a couple of YouTube channels and resources that explain the challenges after the CTF is expired. Keep this in mind. When the CTF is expired, you will get the walkthroughs, and these are the famous YouTube playlists which explain how the CTF is solved and how they have solved it, and was there any other technique to solve it, and a detailed walkthrough of the CTF. The other platforms that I focus is on TryHackMe and Hack the Box. These two platforms I personally used myself. I prefer Hack the Box more because it is they just give an IP address and then you are on your own, and you have to go on your own basically to pawn the entire machine. I'm currently in top 50 in Canada, and yes, the thing that I admire about these platforms is they have their own machines in various operating systems such as Windows, Unix, Linux, and even recently they released an Android operating system. They also have CTF challenges. The technical skills that are learned or need to solve these machines are pentesting, pivoting, and privilege escalations, as I mentioned. These are absolutely free, and these are absolutely free for anyone to sign in, to log in, to register and go ahead and play with it. One of the best resources that I found is the Portswigger Labs. They have their own academy where the blogs are written by industry experts on various web application techniques such as SQL injection, XSS, and SSRF, and a bunch of other vulnerabilities. It is completely free. You have to register, and then you can solve exercises on those labs. Portswigger is a company which is the owner of Burp Suite. There was also a book released, Web Application Hackers Handbook, and all the exercises that were as a demonstration in this book are I think a part of the Portswigger Labs Academy. The last and final resource that I would like to share, and this is a bit in-depth resource, that is Pentester Labs and Pentester Academy. This is not a free resource. It is a paid resource, but it is kind of very much in depth in terms of a particular knowledge or skills. For example, learning buffer overflows and anything on the binary side. They have dedicated labs, and they have like 35 labs for each of the various techniques. For example, packet analysis and everything. So they have demos and practice on their site, and one should really check it out. This should be the last step to check it out, as you should go over the open source and free resources. The last thing that I always focus on is certifications. I highly recommend OPSEC certifications, but if you're a beginner, then going for an OSCP would be quite tough for you. So other side of certifications that I recommend is Ellison security certs. They also have gained a lot of popularity in the market. And finally, I would close with the responsible disclosure. Responsible disclosure is kind of like bug bounty, but it is like a company or a set of companies have already declared a responsible disclosure and the scope of their assets, and you can go and find vulnerability flaws on it, and you can report it to them. When you report it successfully, and if you are the first one to report, they send you a swag or a hall of fame on their website, and that you can easily write on a resume. But this should be a final step, as this is not like a real time. It is a reality. So if you directly jump onto this step, then maybe you would get demotivated, and then you end up in a different field. So this is the last thing that you should do. Finally, I have made a list of all the content creators. This is not a complete list, but this is of the majority of the content creators in InfoSec industries. They have their blogs, they have their YouTube or Twitch channels where they stream and demonstrate a lot of other technical aspects and things. My favorite is the Buckcrowd University and Level Up, where NahamSec and other professional bug bounty hunters share their knowledge and their recon and other processes. Conclusion, my advice is that if you pick any of one resource, stick to it and try to complete it, or try to make the most of it. I don't want anyone to hop on a resource and then after a few days they will hop onto another resource, and yes, so this is it. Thank you for having me, and I would take any questions and answers.
Fantastic. Thank you, Hirsch. Let's look at the chat, see if there's any questions that you haven't answered along the way. I see a lot of great tips, comments there about Try Hack Me, which is great for beginners. There are a few more tips in there people have shared. Any questions?
Yes, for a beginner, HTTP is hard because they just give you an IP address and there are no further steps in it. But and that's why it has a wider recognition in the industry. But for HTTP, you can watch AppSec videos on YouTube where a machine retires and AppSec solves it and explains the entire process. It's like a 1 hour, 2 hour video. And probably if you go for an easy machine that is a 20-point machine, it is just finding a CVE and a bit of a recon process. Other question, I have already uploaded the slide on GitHub. I will post the link in the description. And
oh, there's a last question there from Mark. In your day-to-day offensive work, do you reference industry frameworks, pen tester framework?
Well, it is better. It is as a methodology, it is better to follow a framework to get everything in organized. But a lot of these frameworks does not cover that is logic flaws and business logic flaws. So you should consider it, but you should totally not rely on it. That is the advice I would say.
Okay.
Yes. On Try Hack Me, they have this walkthrough rooms such as OSCP walkthrough room. They also have a Pen Test Plus walkthrough room, and they have some CTF walkthrough rooms as well. But if you are a beginner, then you should see the difficulty of the walkthrough of the room, and then you should jump on it, because there are certain rooms that are considered as insane in difficulty or hard in difficulty level. And if you try with those, and if that is your first room, then eventually you would definitely get demotivated or pissed off on your side.
I think that's it. Oh,
yes, I think that's it.
Fantastic. Well, we are right on time. Hirsch, thank you so much again for joining us, speaking for the first time. That was wonderful. So great to have you join us and speak. I know we've been working over the last 1 year, and I'm sure there's going to be many, many more talks that we're going to see you at other conferences. So looking forward to more talks that as you continue on your journey in this industry.
Yeah, actually one last thing, whenever I present, I always create a CTF challenge for the audience. So I have created a CTF challenge in this case, and basically it's like a recon challenge, and you would find something on the internet related to me, and if you find it, you can use it. That would be the only hint I would say at this moment.
There we go. Fantastic.
Thank you.
Awesome. Thanks so much again. Our next speaker is Donovan Ellison. A little bit about Donovan is a site reliability engineer that graduated from Portland State University last year and started getting into security shortly after. He is interested in high assurance systems, DevSecOps, and container security. With that, I'm going to pause and hand this over to Donovan.
Thank you. I'll share my screen. So my name is Donovan. And as you might have heard, I'm a site reliability engineer at Zapproved. My presentation is on commanding your instances with AWS Systems Manager. A few months back, I started looking into AWS Systems Manager, which is an AWS service that lets you manage your AWS resources. Our team wanted to know what we could use it for, how it compares to other things, and what potential benefits we could use from using it. And I wanted to share what I learned about managing EC2 instances, what wasn't clear in the documentation, and what I found useful, with an emphasis on how you can improve your security posture through locking down access to your instances, and understanding how these capabilities work. So the main takeaways from this presentation will be how Systems Manager talks to and tracks EC2 instances, the benefit of connecting to instances with Systems Manager, how to send commands remotely and securely, and how to monitor your systems and maintain your system configurations. So to start, there is an SSM agent that runs on your instances. And what it does is it talks with Systems Manager, and it runs as sudo or admin on your system, and it applies whatever configurations it gets from Systems Manager. It's responsible for basically everything that happens on your instance, and is responsible for talking to it as well. So that means how you use an SSM agent is you first have to make sure it is installed and running on your instances. And that's pretty easy to do because most armies have it installed by default. And then you have to make sure it can talk with Systems Manager. Generally, it can't talk with it unless you give it permissions to talk with it. And that's usually sorted through an instance role that's attached to your EC2 instances. You can give it different kind of credentials if you want it separate, but generally it's about giving your instance role the proper permissions to manage it. What is the first thing you might want to do with this new capability you have is connect to the instances using Session Manager. Session Manager allows you to request a connection to an instance through the console or the command line, and it will create a user for you to use with specific permissions that can limit or escalate your privileges on that instance. And then it will start a session with you using that user profile. This is really handy if you have different kinds of users in your accounts that you want to have different levels of access in your instances. Sometimes you just want people to be able to jump in there and read what's going on. Sometimes they need admin access to debug what's going wrong and to really track down things. The reason you might want to use that Session Manager is that typically to connect to an instance, you have to use SSH, which requires managing a private key, perhaps distributing that private key between people if multiple people need to get access to the same instance, managing a security group that allows everyone who needs it access into the instance. Maybe if you don't want to open up ports on that instance, you can set it up in a VPN with a Bastion server that you SSH into first and then SSH into there, but that's a little more cumbersome. And also you still have to leave a port open somewhere. And the worst of it is that there's no log of these actions or what has occurred on your instances or who has logged in. And it can be easy to erase, the bash profile or where the bash commands have ran, the history of them, so that they can erase their steps. But with Systems Manager or Session Manager, you can control access through IAM policies and roles, both at the instance level and the user level. You can say an instance just can't start a session at all, and then it won't ever be able to. But you can also say at the user level, this user only gets access to these kinds of session profiles, which only have these limited capabilities, such as like they can only run tail on your logs or something like that, but they can't do anything else. And also, most importantly, it logs the session that the user had and who had that session and what actions they took. There is a concern there with this because the default session grants admin privileges to the user. And you have to explicitly force users to select a session. Otherwise, it will allow them to use the default session, even if you deny them access to the default session, which is a little weird and very easy to misconfigure. So be mindful of that. But it's still nice because you can, as I said, restrict the session, change up the profile to have really fine-grained access of what people can even do on an instance and specify even what instances they can connect to. The other thing you might want to do with Systems Manager and the SSM agent is to run commands remotely. This is nice because you can send like any kind of command to the instance, whether it's running a script an Ansible playbook, maybe it's just a bash script, maybe you're doing like a chef cookbook, or you're running some vulnerability scanner, or any of those series of things. It will report that command output and the status back after it's done doing that, and you can view it in the console or through the command line as well. A good reason to use this is that it gives you a consistent way to specify what the desired state of your systems are, and you can repeatedly apply that state as needed. This too allows logging. You do have to enable logging explicitly, which is the same for Session Manager. You have to turn it on the logging to CloudTrail and S3 and point it to like whatever S3 bucket you want. But the option is there and is probably preferable to use. Yeah. And it can also let you respond to incidents remotely and securely. The AWS Incident Response White Paper says it's preferential to use run command when you're responding to an incident by first completely cutting off the instance from everything else, putting in its own network, making sure there's no outbound traffic, making sure it can't connect to or do anything, but you can still run the command on it. And then you can run that command to collect networking data and export the file system or whatever else logging or monitoring things you want to do while it's kind of locked down. There is, again, a security concern here because SSM agent runs as sudo. And so because it's the one that is processing these commands, it can do anything. So you have to be really careful with that and who you're allowing send command access to, if they can like create new ones or maybe just use old ones. But you can restrict who can send commands and what documents to use and where those can be sent to, very similarly to how Session Manager lets you kind of control all those things. Lastly, a really useful feature is being able to run commands periodically or on a schedule. This is with State Manager, where you can associate commands with an instance and a schedule, and that association will get sent to that agent because the agent requests any associations that it should have, and then it will run it when it's time to run that command, and it will then report back to it. This kind of illustrates a nice thing about the SSM agent as well, which is that it pulls the systems manager capabilities, not the other way around, which means you don't really have to keep inventory of all these instances. But as soon as they get started up, you can start using them. Which is really nice when you have like an auto scaling group or something and you want to make sure each one of them have the same configuration or the same thing going on. You can do it right as it starts and then some period of time after that. It can be like a minute, a few seconds, every Wednesday at 4, whatever you want. This is really nice for maintaining the desired state of your system. If you want to make sure that there's only certain apps and processes running or that nothing is getting opened up. It can also be nice for alerting on some kind of misconfiguration or resolving it entirely, whichever is preferable at the time. Yeah, the conclusion is that the SSM agent is really powerful and kind of scary because of that, and to be mindful of that. You can log everything anyone does, but you have to enable it. The session manager is great for locking down access to EC2 instances. Run command can help you automate your incident response, and state manager can give you more confidence in your system state. And that's my presentation. Any questions?
Thank you, Donovan. That was fantastic. Let's look through the chat to see if there are any questions, or feel free to type or unmute yourself if you have a question.
Yeah, we're migrating as well. I found it really useful. There hasn't been too widespread adoption yet, but I'm trying to lead that charge.
Anything else? Any other questions? Okay, I don't see anything else. There we go. Fantastic. I can see lots of great stuff. Great presentations. I want to thank you all the speakers. And this is just to highlight that we're always looking for speakers. As you saw for today, it was lightning talks. For some of them, this is the first time they were presenting. So great job. This is a great opportunity for you to share your research, to practice presenting. We've got mentorship in place where some of the committee members can help, guide you as you're preparing for your talk. So please, if you are interested, please reach out to any one of us on the committee if you're interested in a talk in future. With that being said, well done to everybody. Thank you to the audience. Thank you to everyone that asked questions, making this interactive. And please block off your calendar. September 16th is our next meetup. The speaker will be announced if you just look out on Meetup, or stay tuned if you're on our mailing list. Same time at 6 o'clock on September 16th. More details will be shared soon. Enjoy your evening, and thanks again to everyone.